Okay, good morning, students. So today is the next class of your GIS, and hopefully we will try to complete the fourth unit in today's chapter. I have requested for another class to in order to have a revision of the entire third unit and fourth unit. I hope my audibility is clear. It would be better if someone replies whether my audio is clear or not. Can anyone reply,
Can
students?
anyone reply, student? Yes, sir.
Oh, thank you, ma'am. Thank you so much. Okay, thank you, ma'am. Thank you. Okay, so we will start with today's class, and today what we are going to see is we are going to see what is a network, what are the analysis we could do with the network, what is a network analysis, and what is a DEM model. We actually saw that what is digital elevation model, or also called as digital education model, right? So that's what we are going to see in today's class, and the last topic is 3D data collection and utilization. Okay, so this is what we are going to see in today's class. Digital education model and 3D data collection and utilization are minor topics which you could have a glance on it. So we will focus on network analysis part today, and this is what we have completed so far. And in today's class, we will be completing network analysis, digital education model, and 3D data collection and utilization. Okay. So this is the question for your last session. Last session, I didn't get any answers for this question. So let's see whether we are getting any solution this time. I also have two more puzzles for you guys in this session. Okay. So be active and listen carefully. So network analysis. So now we are going to see what is a network first of all. Okay. So in a very simple task or in a very simple solution, okay, network is nothing but a collection of several nodes combined together. Okay. So when many nodes are combined together, it creates a network. Okay. So now what are the analysis we are going to do in network and why we should do some analysis in that network? That is the main task over here. Okay. So, first of all, in order to answer this question, we have to ask another question. What are the problems which are occurring in the networks? Okay, what are the problems which are occurring in a network? So, we have to get that problems in order to give a solution first, correct? So, what we can do is we have to assume a network, like for example, now there are several kinds of networks. So, as we are talking about geographic information system, we have to analyze or we have to assume a network related to geographic information system. Okay, let me give you an example. A river is a network. Okay, and pipelines are networks. Okay, cable lines, pipelines, water tunnels. Okay, even in some cases highway roads are also connected as a network, right? So what are the main problem for this network is transportation. Okay, or the best route for the transportation. Okay, so these are all considered as a problem in the network analysis, correct? So in order to give a proper solution or in order to give a better solution for these kinds of problems, what can be done is we could do some analysis. So those kinds of analysis is called as network analysis. Okay, so what are we actually doing in network analysis is we are trying to improvise the system. We are acting as a catalyst. Okay, it improvises or it speeds up the process. Okay, so that is what actually is being done using a network analysis process. Okay, so there are several types of examples available for this network analysis. Okay, you guys would have studied design and analysis of algorithm subject, right? So you would have got so many algorithms in that also. Okay, so in that we are going to discuss few examples or few algorithms which is related to this network analysis process. Okay, so what is a network? Network is any system, okay, of interconnected linear features, okay, or interconnected nodes. Okay, so here as we are talking about GIS terms, we are taking instead of nodes we are considering linear features as a particular node. Okay, so a network is a system of interconnected elements, and it has been connected with the help of edges, okay, lines. Okay, and connecting junction are called as points or nothing but nodes. Okay, so that represents possibly routes from one location to another location. Okay, so this is a network actually. So what is a network analysis? Solving problems which is available in the network. Okay, or solving network related problems. Okay, So that is called as network analysis. Okay. So what is the main goal of this network analysis? Maximum efficiency. It should save time and money. Okay. So that is the main objective of this network analysis. Okay. So network analysis actually involves in analyzing the flow of network in a connected to set of lines and points nodes together. Okay, so these linear networks, most often it represents some features such as like as I told you, rivers, it may be rivers or transportation corridors or like roads, railway roads, or even flight path could also have can be made as a network. Okay, you could ask me that how a flight, the path of a flight traveling from one location to another can be given as a network. Okay, all flights has a specific path of flying. It doesn't fly just like that then and there. Okay, so based upon the wind circulation, it has a unique route to travel, which gives its maximum speed and less time to reach the destination. Okay, so this is one thing. And as many points and lines are involved over here, it could be represented in vector format. And also I didn't mean that it cannot be represented in raster format. It can be represented in vector format easily. Okay, so this is about the network analysis. So a very well known, very easy algorithm, the shortest path algorithm. Okay, so one of the easiest topics and one of the what to say, a very interesting topic. Okay, so I know you guys know about this topic, what are the shortest path algorithm, but instead of discussing, we don't have enough time, so I will explain it to you what is the shortest path algorithm, and then we will move on to the next algorithm. Okay, so I will take one example. Shortest path algorithm is nothing but there are several nodes available. Okay, so let's assume that in a city like Chennai, we will have some landmarks. Okay, so RMK Engineering College and uh, what all? Like you could take some malls over there, some museums over there, some IT companies. Everything can be taken into consideration, and we could form a network. Okay, so our best example, we are going to cover like 4 industrial visit in a single day. Okay, so let it be Sriharikota, or let it be BSNL, or some other IT like CTS or Infosys. Okay, so these could form a group of networks. Okay, so now we have to find the best shortest path in order to cover all the nodes within a day. Okay, so that's what we are going to do with the shortest path algorithm. Okay, so first see this example and you will get an idea. I will explain the algorithm. I will explain the example. Don't worry. Just see how many nodes are there in this one. What is the path and how the nodes are being connected. First, analyze the problem. Just see the problem. Okay. So here, how many nodes are available? Totally 6 nodes are available. Correct. So in the 6 nodes, let's assume our source node, RMK Engineering College, is source node 1. Okay. And let's assume 2 is Sriharikota, or 3 is BSNL, 5 is CTS, 4 is Infosys, and 6 is TCS. Okay, so now what we have to do is we are going to find the shortest path algorithm, which means that we are going from the source node, we have to find the shortest path to every node. Okay, so you can see that from 1 only 3 nodes are being connected. So 1 is connected to 2, 1 is connected to 3, and 1 is connected to 4. It doesn't mean that we can't reach to 5 or 6 from 1. Okay, we could reach to 5 and 6 through any of the intermediate nodes. Okay, so the ultimate goal is that we have to find the shortest path distance from the source node to every other node. Okay, so what we are going to do is, so you can see the first image. I hope you can see the mouse cursor. Okay, so this is the first image. So this is a given image. So you can see that with the source node 1, there is a value called as 0. Okay, it means that the distance from the source node to this node is 0, because that is actually the source node, right? So obviously the distance traveling is equal to 0, because that is the actual distance, or that is the actual location. Okay, so what we are going to do is we are going to explore the nearby nodes. Okay, we are going to explore the nearby nodes. So we are going to explore, or we are going to expand this node. So as we don't know the values of the other nodes, the values are given as infinity. Can you see the values? With every with every other nodes, the value given in the initial graph is infinity. Okay, this is actually a graph. Okay, where 1, 2, 3, 4, 5, 6 are vertices, and the intermediate lines are edges. Okay, so a combination of vertices and edges are called as a graph. Okay, and the one in the values in the square bracket is called as the shortest path value from the source node. Okay, so now we are in second diagram, we are going to expand this one. So 1 has a connection to 2, 3 and 4. Is that clear? So as it has connection from 1, 2, 3 and 4, we are going to get the same values for that representative intermediate node. So from 1 to 2, the value available is 3. So the value of the edge is taken as the shortest path of that particular node. Okay, so from 1 traveling to 2, the distance is 3. So from 1 traveling to 3, the distance is 4. So from 1 traveling to the node 4, the distance is 2. So the updated, okay, the updated difference. Okay, so how come the value is being updated is when the value is smaller than the previous value, it will be updated. So initially the value is infinity. So infinity is obviously the highest value. So when we are having a lesser value than infinity, like, so for example in the second diagram, okay, you can see the mouse pointer over here. Yeah, so in the second diagram, so for the node 2, the value has been updated from infinity to 3. Again, for node 3, the value is updated from infinity to 4. And for the node 4, the value is updated from infinity to 2. So now we have expanded one node and we have got the values of 4 nodes so far. Okay, so we have to continue the same process until we explore all the nodes. Okay, we have to expand all the nodes in order to get the total shortest distance. Okay, so now diagram 1 and 2 is over. So now we are coming to the third diagram. So first diagram is the initial diagram, second diagram is the step 1. Now we are going to expand. So from the initial root node 1, there are subordinate nodes 2, 3 and 4. So now which node should we have to select? We have to select the node which has the shortest path. Okay, so out of 3, 4 and 2, I am going to select the path 2 as it has the lowest value. So I am going to expand the value 4. Okay, I am going to expand the value 4. So you could see that there is a dark bold color circle which is available in order to expand that 4. Okay, so here we are going to expand the value 4. So you can see that 5 and 6 are having the values as infinity. Okay, 5 and 6 are having the values infinity. So what I'm going to do is I'm going to expand 4. So here already by default the value of 4 is 2. So we have to add this value and the distance between 4 and the upcoming node. There is actually a calculation and mathematical formula for this. I hope you guys remember the Dijkstra's algorithm. Dijkstra's algorithm is being implemented to find the shortest path algorithm. Okay, so based upon that Dijkstra's rule, actually it is pronounced as Dijkstra's. So based upon the Dijkstra's rules, so from node 1 to node 4, the distance is 2. From node 4 to node 5, the distance is 1. So 2 plus 1, the value is 3. So the node value of 5 is being updated from infinity to 3. Similarly, for node 6, 2 plus 4, the value is being updated as 6. Okay, so this is the shortest path values when we are expanding only 2 nodes. We should not stop over here. We have to expand our values also. So now I am going to expand the next value. Next shortest value is, so from root node 1, the next shortest path is 1 to 2. So I am going to expand the root node 2. Okay, so now I am going to expand the root node 2. So you can see that there is a dark color border in the way which is available in the root 2. Okay, so what I'm going to do is I'm going to expand root 2. So 2 is connected to 1, 3 and 5. So 1 is already visited. So I'm going to check out the values of 3 and 5. Okay, so by default there is already a value from 1 to root node 3 as the value of 4. Okay, if there is any lesser value, then we can update. Okay, so instead of going from 1 to 3 directly, I am going to 1, 2 and 3. In that path I am going to go. Can you understand, students? So I am going to travel from 1 to 2 and then from 2 to 3. So the distance covered will be 3 plus 4, which is 7, which is greater than the current value. So you can skip this step. No need to update the value. We have to update the value only if and only if there is a shortest value available rather than the existing value. Okay, so now I'm going to the next step. I'm going to the next step, which is 5. So when I'm going to 5, when I'm going to reach 5, okay, again there won't be any change of values and all. Okay, so now the shortest path value for 5 is 3. So if I go through 2 means 3 plus 2, 5 will be there. So it is also a longest distance. So I won't be updating that value. So far now I have expanded 1, 2 and 4 completely. Okay, so now when I expand 3 again, okay, when I expand 3 again there won't be any difference. Okay, again the same value will be there. Okay, so now I have explored the nodes 1, 2, 3 and 4. 4 nodes I have expanded and the values haven't changed for me. Okay, so now what I'm going to do is I am going to expand the value number 5. I'm going to expand the node number 5. Okay, so how many nodes are connected to 5? So the nodes which are connected to 5 are 3, 4 and 6. Okay, 3, 4 and 6. So what I'm going to do is 3 is already visited. So even if I come across with 5 means there will be a greater value for 3. Okay, so I'm not going to exist that value, and I can't take the value of path 4 because that is the path which I got the value as 3, so I can't take that. And if I take the root path of 2, then it is also again above the value of 3, so I'm not going to skip that. I'm also going to skip that value. So finally, if I am going to expand the node 5, I can only change the value of one single node, which is node number 6. Okay, which is node number 6. So watch carefully, students. So here before this step, the shortest path value for the node 6 is equal to 6 itself. Okay, and what was the path from that? 0 from 1, 4 and 6 was the path. So 2 plus 4, you have got the value as 6. Okay, but from 4, if you take a diversion and go to 5 and then reach 6, then there is a shortened value. So from 1 to 4 the value is 2, from 4 to 5 the value is 1, and from 5 to 6 again the value is 2. So 2 plus 1 plus 2, the answer is 5. So the previous value was 6 and the updated value was 5. Can you understand, students? So after exploring 6 again, completing the exploration of all the nodes, so this diagram, you can see my cursor. So this diagram has the shortest path algorithm or shortest path values for all the nodes from the source node. Okay, so from 1 to 2 the value is 3. Again similarly from node 1 to node 6 the value is 5 using intermediate nodes. So this is shortest path algorithm which solves the problem or which solves a huge problem of saving the time and money. Okay, so this is one of the main example of network analysis. Okay, is that clear, students? This is your first example. If you have any doubts, please feel free to post your doubts in your chat box. Not at all a problem. Okay, so now we will move on to the next problem or next example of this network analysis, the traveling salesperson problem. Okay, so this is also similar to shortest path algorithm only, but in shortest path from one source node we will find the shortest path to every other node. Okay, but in traveling salesperson problem, let's assume there is a salesperson and he have to move approximately to 7 nodes or 7 destination in a single day, and he have to travel all the roads exactly once, or he has to visit all the nodes exactly once. Okay, so now this is the problem and this is the solution. I am going to explain the problem and explain the solution. Okay, so here what happens is let's take the source node as 1. Okay, so we are starting with the source node, and there are, when we are expanding the source node, we could see that there are 3 destinations at the neighboring at the neighboring place. Okay, so near to the node 1, 2 3 4 2 3 7 are its neighbors. Okay, 2 3 7 are its neighbors. So finding the shortest path between these 3, 2 3 and 7, we can find that 10 is the least number, so we are proceeding from 1 to 3. Okay, we are proceeding from 1 to 3. So this is called as implementation of a greedy algorithm. Greedy algorithm is nothing but to find a temporary best solution. Okay, to find a temporary best solution, that is called as greedy algorithm. Okay, sorry. Okay, excuse me. So from 3, we are going to move to the further place. Again implementing the same algorithm. So we have to see the neighboring values of 3. So 3 is being connected to 1, 2, 4, 5 and 7. So the node 3 is being connected to 5 nodes or 5 neighboring nodes. Okay, so what we are going to do is we are going to look at the shortest path. We can't select one as that is the path in which we came. So excluding the node 1, we have to compare the remaining 4 values. So 3 to the node 2, 3 to 4, 3 to 5 and 3 to 7. All these paths has to be compared. Okay, so 8, 11, 3 and 9. So comparing all the 4 values, obviously the shortest value is 3. Okay, so from node 3, okay, so far we have started from source 1, we have reached the source next node 3. From node 3 we are moving to node 5. Okay, so now we have to listen very carefully, students. So listen carefully. So now from node 5 we have 3 more other intermediate nodes rather than 5 3 edges. Okay, so the remaining values from node 5 is 11, 6 and 7. Okay, so obviously the lowest value is 6. Okay, so just assume we are proceeding in the value 6. Okay, if we are proceeding to the value 6, we will be reaching the node 6. Okay, so if we are reaching the node 6, then we will have a dilemma. Okay, and the dilemma will be the shortest value of 9 and 10. Obviously the shortest value will be 9. So after starting from 1, reaching 3 and then 5 and then 6, if you go back to the node 7, okay, if you go back to the node 7, there is a problem occurring as that we will reach a dead end. Okay, and we could not cross the same node twice, correct? So due to that problem, what we are trying to apply is we are going to apply backtracking solution or backtracking algorithm. As this solution is a dead end, which is a dead end 1 3 5 6 7. Okay, 1 3 5 6 7, this path is a dead end, as we could not trace the remaining nodes 2 and 4. So we are backtracking from 7 to 6. Again we are backtracking from 6 to 5. Now we are going to choose an alternate path. Okay, so the shortest value is 6, so we are selecting the next shortest path, which is 7. So now the modified shortest path or traveling salesperson path is we are starting from 1, then going on to 3, then 5 and then returning back to 7 or going to 7. Okay, so now the next value is, so from 7 you have 3 values 12, 9 and 9 again. Okay, as 1 and 3 visited, the only other solution is 7 from node 7 to node 6. So the value from node 7 to node 6 is 9. So now we are back on track. Okay, so now what is the path for us? 1, 3, 5, 7 and 6. Hope you guys are following me. So after 6, now we are going to expand further. Okay, we can't go back to 6 again as it is already visited. So the only remaining path is from 6 to 4. Okay, again from the node 4 is the only remaining path is 2, and from 2 we are going to reach back to the starting source itself. Okay, so this is the traveling salesman problem and the solution. So the final path of the traveling salesperson in order to reach all the nodes with the shortest time and duration, the path is first he have to start from 1, then he has to go to 3, 5, 7, and then he has to move on to 6, then 4 and 2, and finally reach back to the destination source itself. Okay, so this is the traveling salesperson problem and the solution for that problem. Okay, so there is also a similar type of problem with this traveling salesperson problem, which is waste collection process. Okay, so let's assume there is a city like Chennai, so and there are several hotels available in Chennai, and from the several hotels what is happening is we are going to collect the waste material of that particular hotel. Okay, so we have to collect, let's assume that we are going to collect the waste material of 10 hotels. Okay, the main problem is that which hotel to cover at what time or at what process. That is the problem. Okay, so if we start collecting hotel at one place, we have to cover the nearby hotels first, correct? We couldn't start one hotel at North Chennai and the second hotel at South Chennai and again coming back to the North Chennai. That is a waste of time. So this traveling salesperson problems gives us a solution in order to cover all the hotels in such a way that it travels in a minimal distance with minimal time. Okay, so that time and distance and money, everything is being saved. So this kind of process is called as network analysis. Okay, is that clear, students? Okay, if you have any doubts, please post your doubts in your chat box. Not at all a problem. Okay, and this is one of the important problems available in network analysis: the shortest path algorithm, the traveling salesperson problem, or waste collection vehicle process. Waste collection vehicle process. Is that clear? Hope it's clear. And the next one is location allocation modeling process. Okay, this is also similar to waste collection process only, but what we are doing over here is instead of collecting the waste, we are going to supply the goods actually. Okay, we are going to supply the goods. So how are we going to supply the goods? So we have to create a mode of transportation and the best route for uh, transporting that goods material. Okay, in such a way that the goods are being received or the goods are being delivered in that proper location at minimal time. Okay, so this is also called as vehicle routing process. Okay, so I'll tell you that. So in location allocation modeling, like for example, there is also another example. So one example is that supply with the goods wherever it is necessary. That is one example. Another example is let's assume there are several schools available in a particular area. Okay, so we have to create a best location. In order to establish a new school. Okay, so we have to see that where there is more people located or more populated area, so that we could get more admissions for that school. So those kinds of things has to be taken, and the transportation for those school for the nearby areas, that has to be taken into consideration. Okay, so after taking into all these things into consideration, we have to give a, what to say, an optimal location where a school can be created, where it doesn't disrupts the what to say it doesn't disrupt the entire network, and it doesn't create any new problems and all. So we have the, if we identify the optimum location for, that will be the network problem in these cases. Okay, I'll explain it again. Let's assume that there are several schools available in a particular area, and every school is being running successfully with a nearby populated village or something like that area. Okay, so obviously the constraint will be that the traveling time should be very less for the people to travel from their village to their schools. Okay, so based upon that, there is a network which is being formed with all the schools, intermediate schools available. So when we are trying to find the optimal solution in order to place a new school, then we have to check whether the network transportation of the village as well as the remaining schools as well as the new optimal school which we are going to implement. Okay, so this creates a network problem, and finding the solution is a main network analysis example or network analysis application. Okay, the next one is vehicle routing process actually. Okay, so what is vehicle routing process? I'll tell you that. Like the vehicle routing problem is an extension of traveling salesman person only. Okay, so given a fleet of vehicle and customer, the main objective of the vehicle routing problem is to schedule vehicles or routes and visit to the customers in such a way that the total travel time is minimized. Okay, so this is actually the main problem of route tracing or vehicle routing problem. Okay, I'll tell you again. The vehicle routing problem is an actually an upgraded or extended version of the traveling salesperson problem only. But here, let's assume like we are the owners of Ola or any fast track or anything like that. So here we are given a fleet of vehicles and a list of customers are available for us. Okay, the main objective of the vehicle routing problem is that we have to schedule a vehicle route, okay, a particular route in such a way that it visits to the customer in such a way that the total travel time is been to the minimum level. Okay, so maybe the shortcuts or the shortest path, everything, the shortest path are also um, depends upon the road traffic or any road damage or road blocks. All other things are taken into consideration, like traffic congestion, any other problems which can be created in order to slow our process, okay, or slow our traveling process. So this is vehicle routing problem. Okay, so is this clear, students? So far we have seen four types of network analysis. So the first one is the shortest path algorithm, second one is the traveling salesperson problem, and third one is location allocation modeling, and next one is route tracing process. Okay, so far any doubts, student? Okay, so if you have any doubts, please post it in the chat box. Okay, so now we will go back to the next topic. So before going to the next topic, I want answer for this question. If you have the answers, you can post your answers in the chat box. Students, if you have the answer for this problem, you could post the solution for this in the chat box, or at least the nearby solution if you get anything. Anybody got the solution? At least any? Wow, excellent. Very good, Manjali. Anybody else got the answers? Any other students got the answer? So okay, so not a problem. So very good, Manjali, very good. So I would like to have some more answers. So I will tell the answer at the end of the session or in the next class. Okay, don't worry. But I was really not expecting just one reply for every student. Maybe this may be a little confusing or little tough, or I don't know. So it's not a problem. We will go to the next problem. I have more problem for you guys. Don't worry. But we will definitely discuss the answer. Let's also see whether some other students are having the any different answers or not. Okay. Okay. Very good. Super. Okay. So now I will give you the problem for the next question. So the next problem. This is your next problem for the next session. Try to crack the code, students. So now we will move on to the next topic. After completing the second topic, we will discuss the answer for this question. Okay. So the next one is quantitative spatial analysis. Okay. So what is quantitative spatial analysis that we are going to see in today's class, or in the next topic which we are going to see? Actually, there are three main types in quantitative spatial methods. Okay, I'll tell you that first. One is exploratory and descriptive statistics. Another one is predictive statistics. Another one is prescriptive statistics. Okay, these are the three things which is available in quantitative spatial analysis. So first, let me explain what is quantitative spatial analysis for you guys. Okay, it actually allows the ideas about spatial processes and patterns to be tested, and it is being used to help find the meaning in spatial data. Okay, so quantitative analysis methods can reduce large data sets to smaller amount of more meaningful information. Okay, like for example, okay, if you are attending a placement question or placement interview, okay, so you are having an online exam of placement test and all, or maybe AMCAT or SMART, anything. So the question for you is, a passage will be given to you. Okay, so a huge passage will be given to you, and that from huge passage there will be 4 to 5 questions asked to you guys. Okay, so there will be 4 to 5 questions which will be asked to you guys. So what you will do, will you keep on read the entire passage together? No, it will take more amount of time, right? So rather than reading the entire passage, you will read in a hints or short form, in a smaller way, that you could understand the gist of that entire passage. Okay, you could understand the gist of the entire passage. So here, quantitative spatial analysis is nothing but analysis done on the spatial data. Okay, in such a way that the huge amount of data is being compressed in a simpler format and easier format in order to solve our question or solve our query. So that is quantitative spatial analysis. Okay, can you understand? So now just see the first point again. Quantitative spatial analysis allows ideas about spatial processes and patterns, or it's checking for any new patterns or any comprised techniques is available to be tested, and it is used to help find the meaning in spatial data. Okay, it is comprising the huge amount of data into a smaller amount or in a meaningful information. For what? In order to help us in order to solve a particular problem or to give a solution for a particular query. So that is quantitative spatial analysis. Okay, so what it happens is it explores the entire data and it gives some theories, it gives some solution, it comprises the data, everything is being given. Okay, this technique is called as exploratory data analysis. Okay, what is it called as? Please note it down, students. Exploratory data analysis. Okay, this technique is being used. Okay, so it explores all the spatial patterns, it tests the different hypotheses. Hypothesis means theorems. It's like trial and error method. Okay, it tries some technique, it tries some theorem, and if that theorem works out, then it will give us a fruitful meaning, or it does give us a better efficient meaning. So it is exploring the data, trying some theorems, applying some patterns, and then getting a final output. Okay, so that is what is being done with the quantitative spatial analysis process. Okay, so also in quantitative methods for spatial data analysis and all, some development like distinct from some developments are very distinct, okay, from other spatial methods and all. Okay, like it is used for non-spatial data also. Okay, not only for spatial data, even for attribute data, because of the distinguishing features of all the spatial data. Okay, so every spatial we know that every spatial data has its own features and its own attributes, correct? So not only the spatial data are being analyzed and given a fruitful meaning, but also the non-spatial data like the attribute data are also implemented and analyzed and shortened into some reduced meanings also. Okay, and observation of the spatial data are not independent. Okay, observation of these spatial data and all, it's not like anybody can access the any data, it is not like that, but it is assumed that the features that are close together in geographical space are in some way related to this one. Okay, so actually this is the first law of geography which has been implemented by the person called as Tobler. Okay, you know who's Tobler, the father of GIS, Tomlinson? Yeah. So what he has told is the observation of spatial data are not independent, but it is assumed that the features that are close together in geographical space are in some way related with each other. Okay, and it also produces some different results can also be obtained from this process. Okay, rather than trying in a straight trial and error method, if you are trying some randomized techniques, we will have some randomized results, obviously. Yes or no? Yeah, so different results can also be obtained when applying the same technique to the same distribution of data, simple just by simply by varying the spatial units which is being used. Okay, so this problem is also known as modifiable areal unit problem. Okay, this is also called as modifiable areal unit. Please note down. I have mentioned at some point. Wait. Yes. Look at the third point. The problem is known as modifiable areal unit problem. Please note that. Trying different techniques for the same data set or trying the same technique for different data set. Okay, that is called as modifiable areal unit problems. Okay, so in some way this has helped us to revive the quantitative tradition in the spatial science. Okay, but it is interesting to note that how few statistical analysis tools which is there in GIS software packages helps us to get the solution in a much faster manner. Okay, so as a result, many users have turned to external statistical packages to perform even a relatively simple quantitative analysis. Even like for example, even a small quantitative analysis is being taken up by some external statistical packages. Okay, so that's how they have explored the GIS packages. Okay, however, in all GIS in all the GIS process, it can provide useful data for statistical analysis simply by outputting spatial referenced data in a form that can be read by another package. Okay, so in this process there are three main techniques available. Okay, or rather than techniques, I could say three main methods available. Okay, so one is exploratory and descriptive statistics, another one is predictive statistics, and another one is prescriptive statistics. So these are the three techniques or three methods available in the quantitative spatial methods. Okay, students, please take running notes with by listening to the class then and there. Okay, it will really be helpful for you. So we will come to the first topic: exploratory and descriptive statistics. The word itself gives us a clear meaning. Okay, an exploring of data. Okay, excuse me. Okay, sorry. So the first topic is exploratory and descriptive statistics. Okay, so exploratory and descriptive means what does the word mean to us? It is going to explore something. It is going to what to say? It is going to explore something means it is going to represent something huge. Okay, descriptive statistics means a very detailed manner report. Likewise, okay. So this in this quantitative spatial analysis method, the exploratory and descriptive, what it does is, if any particular spatial data is being taken, okay, if any particular spatial data has been taken, we will be taking the attribute data also. Okay, like for example, distance from one point to another point, or the observation of that point, or lines, or area features, anything like that. Okay, or distance to the nearest observation. So all these factors are taken into consideration. Okay, so these can be used to describe the distribution of the spatial phenomena actually. Okay, for example, I hope you guys know what is a histogram. In DEM model we would have seen a color spectrum. Okay, so that is called as a histogram. Okay, so maybe for example, a histogram may be created to show the distribution of land parcels of different sizes. Okay, or the type of soil available can be represented in a histogram. The quality of water, the type of water resources available in each area. So these things and all can be given in an exploratory and descriptive manner. Okay, so this is one example for this is one method for quantitative spatial method. And the next one is predictive statistics. Okay, we are again, the word is very simple. Okay, so here these are used to look at the relationship between the spatial phenomena. Okay, so if there are multiple spatial objects available, we are going to see the look at the relationship between each other. Okay, so here we are going to predict something new. Okay, so rather than exploring the real data, what we are doing is we are this is what called as analysis, students. This is what called as analysis. So we are going to predict something new. So we are going to compare any two randomized spatial data which is nearby, and we are going to compare any common things together or not. Okay, for example, like have you heard about regression analysis? It is also, it might be used to look at the relationship between altitude and the vegetation type. Okay, like for example, altitude is nothing but the height from the average sea level to the skies. Okay, so as the altitude increases, the type of vegetation changes. Okay, so like for example, if we are putting some crops for cultivation in the roadside or in the cultivating land means, so it has some temperature or it has some basic qualities for which the cultivation has to be done, right? So as the altitude increase, like for example, if you are climbing a hill, the same vegetation which we have done at high temperature in the roadside or at the bottom of the hill, we can't do the same vegetation at the top of the hill, because at the top of the hill there will be a huge rainfall, the climatic condition would differ. So based upon that, we there should be a predictive analysis in order to find the solution for such kinds of problems. Okay, so this regression analysis is an example for predictive statistics. Is that clear, students? Okay, and here we are not only dealing with a single layer of data. Okay, so here multiple input layer are of either dependent or independent variables can also be used. Okay, so for here rather than using a simple regression or single regression analysis technique, we could use multiple regression techniques also. So that will improvise the uh, output of this predictive statistics. Okay, and the last one is prescriptive statistics. Okay, so these are actually used to ask what if. Okay, like it is prescribing something. Okay, it looks for the alternate solution. Okay, or the wantedly unwanted solutions. Okay, so we know that this is the process. It's like a trial and error method. What if this is not happening and that is happening, for trialing something new? Okay, so why we are doing such things, why we are doing some what if techniques and all this, in order to get some new solutions or new dimensions of analysis. Okay, so new dimension of analysis is being taken place over here. Okay, so they actually help with the prediction of what might happen in a particular set of circumstances. Okay, like I hope everybody has watched Avengers movie and all. So in that you would have seen a person called as character called as Doctor Strange, right? So in a scene that Doctor Strange would have uh, he has a power to control the time, something like that. Okay, so what he will be doing is he will be looking for alternate solutions to win a battle. So that is also called as prescriptive statistic. Okay, so looking for alternative solution. So what if this happens, or what if this happens? So looking for alternative solution is called as this prescriptive statistics. Okay, so these are the three main methods of quantitative spatial methods. Okay, so with this topic gets over. So the next topic will be our DEM model. Okay, so this is predictive statistics. Don't worry, I will send you the PPT in the. I will upload the PPTs in the college website itself. Don't worry. Yeah. So the next one is digital education models, or the DEM model, shortly called as the DEM model. Okay. So now we are looking at the almost last two topics. We still have hardly 1 hour, and we will try to wind it up, and then we will have a revision process. Not to worry. So coming back to this DEM process. Okay. Actually, we know that digital education model or digital elevation model are termed as DEM. DEMs are nothing but it is a primary data source. Okay, it is a primary data source for terrain mapping and analysis and all. I hope you guys remember a mountain which has been given in a triangulated irregular network using DEM modulation and all. So the heights are being heights from sea level of a mountain is being given in various spectrum of colors. Okay, I hope you guys remember the diagram. So that is the actual implementation of DEM. So it is nothing but a primary data source of terrain mapping and analysis process. Okay, it is a traditional method for producing the DEMs, which is used to use like a stereo plotter. Okay, the term is called as stereo plotter. That term is being used. Okay, and stereo pairs of aerial photographs. Okay, so that is pairs of aerial photograph of the same area taken from slightly different angles or different position in order to produce a 3D effect. Okay, so you would have seen that DEM model, it would be represented in both height, width, and altitude. Okay, all three dimensions will be there. So that is the actual use of DEM actually. Okay, and the stereo plotter creates a what is the term stereo plotter? Okay, it is used to use a stereo plotter and stereo pairs of aerial photographs. Aerial photograph means photos taken from satellites or through drones or aircrafts. Okay, so a stereo plotter creates a 3D model, allowing the operator to to compile the elevation data. Elevation data in the sense from ground level to the top of the hill. Okay, although this method can be produce highly accurate DEM data, it requires experienced operators, okay, and it is also time consuming, okay. It is not an automized format, so it will be better if there is a supervisor or a person in order to manipulate all these data manually, okay, even though the DEM gives us exact new values or accurate values, okay. So it is also another traditional method, which is to interpolate a DEM from the what is it, by default the contour lines of a topographic map, okay. So you know what is topographic map, right? A topologically obtained or topologically filtered map, okay. So several new techniques for DEM generations have been developed in the recent years, okay. So the main technique are using some optical sensors, interferometric synthetic aperture radar, okay. Interferometric synthetic aperture radar, we will see that in the later slides also, not to worry. Okay, so please note down this term, students. Interferometric synthetic aperture, APERTURE, aperture radar, okay. Short form INSAR, where I is alone small letter, okay. INSAR, interferometric synthetic aperture radar, okay. And also there is another technique like optimal sensoring technique, which is light detection and ranging. Light detection and ranging, so it is called as lidar, LIDAR process, okay. So these are the few models of DEM, actual digital elevation model, and there are some applications for this digital elevation model also, like these DEMs have many applications in remote sensing and mapping areas, okay. Like the term just now we discussed, right? Topographic mapping is also an application of this DEM, and topographic mapping is also called as contour mapping, okay. And there is another application called as thematic mapping, THEMATIC, thematic mapping, or ortho image generation and image analysis, map revision, everything are applications of DEM only, okay. So DEM are very important in providing some valuable geological informations and all, like that can be, which can be used to guide in defining the geology of a given area, any given area, okay. So if a particular pixel of data is being given or a particular given area is being given, based upon the analysis or data given by them, we could give some accurate information or more very valuable analysis regarding to geological informations, okay. So DEM are used to extract information which are relevant to, like for example, groundwater studies, such as potential areas or groundwater recharge or contamination process, something like that, okay. So these are the applications of DEM, okay. So I hope now you can understand what is uh, DEM process, okay. So now what we are going to see is various education segment in GIS, okay, or GIS in education, okay. So GIS in education, in the sense it can be taken as an application oriented process where how GIS has been useful in the field of education, how it has been a more formal as well as informal way of learning, okay. So like for the best example is, I am being a human being or a citizen of this country, okay. I am not getting any formal information regarding this, but I am using this in day-to-day basis, yes or no. So we are using Google Maps daily, so those Google Maps is been giving us some great informations, okay. So those kinds, so that becomes an informal learning process for me, okay. So that becomes an informal learning process for me, okay. So likewise in GIS or in education, GIS plays a very vital role. So currently sorry. So currently GIS dominates at the university levels, okay, where courses in GIS methods and theory are taught in various geographic or engineering business parts and all, or it is available in environmental studies also, okay, and in many major universities and community colleges and all, some type of GIS education is being implemented, okay. So mostly in United States of America, those kinds of countries, these kinds of GIS education has a separate individual course itself, okay. So this is about GIS in education, okay. So I have a graph which is representing the various analysis of this in education part. This is the one. So the various stars indicates the various universities which is implementing the theory of GIS in real time. Okay. So here you could see that Henson Perry map. Okay, this is called as a Henson Perry map. So in you could see the Perry Lee Henson way, or the Perry. Every route is being mentioned with the term called as Perry or the Henson term. Okay, so students actually benefit from using this GIS in many ways actually. So using GIS, it enhances the students' ability to think critically about analyzing the data. Okay, so using this GIS, it promotes students' ability to use the numbers and numeric skills, and to use the tools that facilitate processing, okay, and transferring the information. So in Henson Perry map, linguistic intelligence is being enhanced. How it has been enhanced? It has been enhanced by using GIS. Okay, so by geographic information system, it has been enhancing the linguistic intelligence of a particular map. So what a student can do is, student can develop the ability to read and use the visible symbols, as well as to interest information in word forms. Okay, so this is what a Henson Perry map looks like. Okay, so you could see some every area is being located likewise. So in map literacy is enhanced through the practice of transforming the situational understanding into a visual picture. Okay, so you would have learned the term or heard the term that one picture is equal to 1,000 words. Okay, so likewise they are trying to implement that the data or the importance of, very simple, is that they are enhancing the attribute data of a spatial data. That's all. Okay, so in addition, students also develop the ability to communicate with each other through multiple modes, like written mode or in visual mode or in verbal mode, everything like that. Okay, so the educators, okay, the educators around the world instruct the GIS in two major ways. Okay, so teaching with the GIS and teaching about GIS. Okay, can you understand the difference? Teaching with GIS and teaching about GIS. So here what we are doing, I am teaching about GIS as well as we are teaching with GIS. Okay, how are we teaching with GIS? We have seen many applications like Google Maps, etc., etc. We have seen the latitude and longitude of every location. Okay, one assignment we have given. So we are teaching with GIS and teaching about GIS. Okay, so teaching with GIS is an what to say? It is a very instructional tool. Okay, so it helps the students to think critically, engage in inquiries, and to solve the problem on their own. Okay, so this is about the Henson Perry map. Okay, and next thing we are going to see is the history about this education. Okay, so how was this education come across, or from where it is coming from? So this is nothing but geographic information system, and the concept about geography, or the maps, or the uh, locations or the boundaries of any countries is being struggled, or has been created as a problem for several centuries. Okay, or even for several thousands of years, these maps and any area or boundaries are being implemented or drawn, correct? So in one of the earliest books teaching geography, okay, Geographia, Geographia, it is a book which is written by Claudius. Uh, I couldn't spell it correctly. I think it is Ptolemyus. Claudius Ptolemyus. T is silent. Okay, so he is a very famous writer, and he's been writing that book called as Geographia. So it is based upon the work of Marinus of Tyre, and on the Asian, Persian, and Rome. Okay, so based upon those data, he has written that book. Okay, so initially, geographic education focused on teaching maps. Later, geographic information system educated was concentrated in the domain of universities, like in order to solve some actual real-time problems. Okay, so that is creating a huge open area for us. Okay, so as these institutions like this education was achieved primarily through trial and experimentation process, and now it has its own separate courses, etc., etc., like that. Okay, so now we will see the various types of GIS education and move on to the next topic. Okay, so the various types of education in the sense how was this education in universities, how we are taking offline classes as well as online classes in GIS. Okay, so GIS education in professional development process, so those all can be taken into consideration as the various types of GIS education. Okay, so the types of GIS education is how the education of GIS has been implemented in universities, how it has been taken in some online courses, okay, and how the education is given by the professional development or the end users or the developers themselves. Okay, these are the actual formal courses which is being given by GIS in any type of universities. Okay, so if we are reading the GIS alone, how much could we get the knowledge? Okay, I mean the delivery of GIS. Okay, how the content will be delivered. Okay, so if we are just reading the concept, we will understand, or that concept will be just delivered to 10% only. If you are listening properly, means then we can understood the concept or the content can be delivered up to 30%. Okay, and like shown over here, if we are using some multimedia presentations or some pictorial representation or easy manning representation, means we could understand of multimedia. With the help of multimedia, we could deliver the content to 50%, but the actual main important or the most advantageous technique is practice. We have to practice again and again in order to deliver the education, or in order to obtain the entire education in a proper manner. So keep on practice in order to get the work done. Okay, so application of this in education is what we have seen so far. I just want to tell you one thing. In digital education model, okay, so in digital education model, uh, that actually digital education model can be described in three categories. Okay, I just want to share that information with you. What are those three categories? Is using like just desktop software to manage data and generate maps. Any desktop software you can recognize now? Any GIS tools? I hope you guys remember ArcView, ArcGIS, Grass, those kinds of tools. Yes. So using those kind of GIS desktop software, we could manage the data and generate the map. So that is one category of GIS in education. Okay. Next one is involving GIS internet application. Just like we have seen online implementation of GIS education. And the third one is dealing with GIS application in school areas or school curriculums. Okay. So that is also one type of innovation or improvisation we could do in digital education model. Okay, so we could also see the various trends in this education, what are the trending topics, or how this has been analyzed in every examples. Okay, how this has been taken in elementary education, how it has been given in higher education. So everything will be given in the slide. So just give a glance of it. Okay, so here we are going to see digital education models. There are two models of digital education. One is Mal Lee and another one is Roger Brody. Okay, one is Mal Lee, Mallee, Mal Lee, and Roger Brody, Brodie. These are actually two digital education model techniques which has been implemented in real time. Okay, so there are actually a huge lot of data we could keep on go across just in education. But based upon these two models like Marley and Roger Brody, from the introduction of the internet, okay, which was in 1993, uh, the world has experienced these two models only in digital education. Okay, that is outside the school and within the school. Okay, so we are not only learning within the school area, or we are not only learning within the college area, we are also learning many things apart from studies inside the classroom as well as outside the classroom, correct? So based upon that strategy or that technique, this Marley and Roger Brody education model was invented. Okay, so outside the young and digitally connected families of the world, employed or unseen the naturally evolving, like what to say, rather than the academic process, we are also learning some new things, right? So like for example, a disciplined manner of living, professional way of behaving. Okay, so those kinds of things are also taken into consideration, right? So those kind of education techniques can be implemented in GIS or in digital education models. Okay, so that is also one example. So like for example, after in the 20th century, I think from 2010 to 2012, uh, the situation actually tends to change when a handful of digitally mature schools began genuinely collaborating with their families in the uh, three what to say daily basis in order to discuss about the digital education with the students. Okay, or digital education about the students. So daily comparison of the parents and teachers has improvised this Mal Lee and Roger Brody technique. Okay, so those schools have reached the evolutionary stage when their teaching models and culture closely mirrored that of the families. Okay, so based upon those discussion with the parents and those collaboration, they could have some new kind of area, new kind of data for analysis process also. Okay, so what are the various learning environmental various learning environments which are available? Okay, so we can see that internet is a very huge source for us. So the digitally connecting family was one of the very important role which was invented by Marley and Roger Brody technique. Okay, so comparing the data of the student by the teachers and the staff member, by the staff member as well as a parent, will bring us a huge difference and huge reality about the exact students. Okay, so I know how you guys are afraid about the parent teachers meeting. Yeah, so that is the exact scenario for, or exact idea for this Marley and Roger Brody technique. Okay, so the last topic of this fourth unit is 3D data collection and utilization process. So we will get back to that topic. So a three-dimensional data collection and utilization process. Okay. So this is the last topic of fourth unit. So we will have a discussion about this now. And okay, so before going into this topic, have you got the solution for the problem which we have given? I'll show you the problem again. Have you cracked the code? Students, if you have cracked the code, you could put your solutions in the chat box. Excellent. You guys are on fire. Very good. Oh, sorry, I didn't see the comment. Uma Devi have asked us a doubt. Can you repeat, please? Which topic you have asked, ma? If you have come across this topic, means you can ask later also, not an issue. If you wow, excellent answer, students. Very good. Everybody got the unique answer. Wow. Excellent, excellent, excellent. Okay, so we will be going to the last topic now. Oh, you got it. Super, ma. Okay. And yes, the answer is correct. You have cracked the code very brilliantly. Because one number is correct and well placed, from 682 is 2, so 2 is the right position, and one number is correct but in the wrong place, which is 4, and the two numbers are correct, which is zeros and twos. So 2 is 0 cannot be placed in the units place or tens place, so the value is 0, 4, 2. Very good, students. So, okay, we will move on to the last topic. Before moving into the last topic, students, do you want another problem like this? Students, if you want another problem, just tell me, else we will move on to this topic. If you want another problem, I will give you another question. And then we will move on to the last topic, and then we will discuss the answer by 4 o'clock. Yes or no? I am expecting a reply. Or else, if you know means we can move on to the next topic, not at all a problem. If you want another question, I will give you one. Okay, so no questions asked. So then there is no more puzzle for you guys if you don't want any. So we will move on to the last topic of 4th unit. So please listen carefully, students. Yeah, so this is the last topic, 3D data collection and utilization process. Okay, so now what is this three-dimensional data collection and utilization process? Okay, I'll give you one example. We'll give some lots of example, don't worry. So how this data collection or how this data is being utilized in a three-dimensional manner means it is not a 3D image or what to say, a pictorial representation or something like that. Okay, so here when an object is being rather than represented in a three-dimensional process, it is being analyzed in a three-dimensional data. Okay, like in geographic information, what is geographic information actually? Geographic information is nothing but the collection of information about places and events that occur on the earth surface. Yes or no? Yes. Yeah. So now geographic information system we know. Okay, what is geographic information science? There is a term called as geographic information science. So GI science. Okay, GIS. So please don't pronounce like that. Geographic Information Science. Short form is GISCIENCE. GI Science. Okay. So what is this GIS or what is this Geographic Information Science? It is nothing but it is actually a study of organizations and tools associated with the process of collecting and disseminating the geographic information. Okay, which means that it is a study of several tools which has been analyzing the spatial data, and that process of collecting those data and segregating the data in a particular manner. Okay, so that is called as geographic information science. Okay, students, please don't leave the session. This is the last topic and it is also very important, so please don't leave the session. Listen carefully. Okay, we will finish it off and then we will have a quick revision, don't worry. Okay, so this geographic information system, okay, it is actually a system for input, storage, manipulation, and summarizing, editing, and querying and visualizing the geographic information. Okay, so now the terms which we use in this geographic information system. Okay, now I told you a definition, right? Geographic information systems are systems for encouraging are systems for input, storage, manipulation, and summarizing, editing, querying, visualizing the geographic information. All these things are done in a three-dimensional data collection and utilization process. We are going to analyze the data in such a way that we redeem the output, or we get the best outcome of each data. Okay. So what are the various options available is surveying can be done, remote sensing can be done. Yes, remote sensing, surveying, it can be implied in maps, it can be implied in cartographies. Okay, there is a term called as geo visualization process. Okay, there is a term called as geo visualization process. Even in that one, all these data can be implemented. Digital globes can be created. Like digital globes are three-dimensional representation of the earth, okay, in high resolution format. The aim of a globe is actually to reduce the distortion, and it reveals the spatial relationship between the places. Okay, so digital globes are one which provides many advantages, like the user is able to scale up or down with the ease, since they are highly interactive. Okay, so these digital globes are easy to transport, since they are accessible on mobile or in desktop phones or desktop computers, or etc etc. Okay, so similar to this, only geo visualization is another process. Geo visualization is the display of the geospatial information to be explored interactively in an effort to facilitate the process of hypothesis formation and knowledge. I told you what is hypothesis, right? Like a theory or prediction, that kind of thing. Okay, so data exploration is an individual activity in which unknown spatial patterns are being revealed in an interactive environment. Okay, so this is also one kind of application in this three-dimensional data collection and utilization process. These are the areas where we are implementing these things. Okay, so what are the areas? Surveying, remote sensing, maps, cartographies, geo visualization, digital globes. Okay, even if you take digital globes, you could I assure you that every student are involving in using some digital globes daily. Okay, so what is a digital globes? A Google map is a digital globe. Okay, a Google Earth is a digital globe. If you want some more example, means Open Street Map, Yahoo Maps, MapQuest. So these are all some digital globes available, and these are also very upcoming trending applications in this 3D in this 3D data collection and utilization process. Okay. Also, I just like to give few more examples. Like GPS is also one of the very important application, global positioning system, or where how the data is being manipulated very easily from huge amount of data. So location based service is also there, LBS. And the last one is volunteered geographic information, VGI. So these are actual data or actual applications of three-dimensional data collection and utilization process. Okay, and okay, I just now saw your message, ma. Okay, I will post the question soon. Don't worry. So besides these applications and all, okay, so we have some more general issues in order to which we have to solve. Okay, so like for example, so far we have seen the positive things about this uh, applications and this and all, right? So now we are going to have some issues which has been emerged. Okay, so first one is LOD, or the levels of details. Okay, so when we are having the details from a spatial data, we are, what is our ultimate aim? In order to solve a problem, in order to solve a query. Okay, so our levels of details will be across that problem only, or across that query only. We won't be seeing some generalized data, correct? So indeed, when we are having a 3D reconstruction data, okay, or three-dimensional analysis of that data, okay, so often that data is been circulating that particular query alone or particular problem only. Okay, so this is also some issues, or it can't be told as an issue, but some if this has been avoided, we could have some more analysis data. That's what we are trying to say. So like here, level of detail is nothing but the detail which is concerned to that particular problem alone or that particular query alone, that has been given over here. Okay, so if the data or the analysis been or the data which is being provided, which is not particular to the level of query, but also in a generalized manner, means we would have got n number of analysis part and n number of new kind of data we would have retrieved. Okay, but we can't tell this as a problem, because our the main utility or the main usage of our GIS process is that we have to find a solution for a query. Okay, so rather than finding a query, we can't do some random analysis to while away our time. Okay, so that is also one of the very important technique, or this is one of the problem which we have to face. Okay, and then standard output. So what is standard output means? Formalizing and standardizing the output of the reconstruction process with respect to formal models and scheme various schemes available as defined in the OGC is becoming increasingly very important nowadays. Okay, so currently most of the algorithms for this 3D reconstruction results in a proprietary format only, so no open sources available. That's what they are trying to say. So both with specific feature definitions which frequently disturb or import or export, and often led to loss of the data. So that creates a issue for us. Okay, so this is what to say, the geometric detail or the texture details that has been taken as a issue over here. Okay, and likewise integrated 3D data acquisition and 3D modeling, including the subsurfaces like objects such as geologic bodies, seabeds, utilities, underground constructions. All these things are also taken into consideration in this integrated 3D data acquisition and 3D modeling process. And change detection, like detection of the changes is going to play a very crucial role. Okay, like for example, even just a very simple example, take an example of your nearby located area itself, your home area itself. Is your area as same as that which was past 20 years? No, there is a lots of changes in your area itself. There are some new buildings, there are new restaurants, there are new malls available, new metro tracks available. So there are huge amount of changes available. So as these changes are automatized, these data has to be saved in a particular manner that the updation of this data or updation of that location has to be maintained. So detection of these changes plays a very crucial role. Okay, and the last technique is monitoring the dynamic process. Dynamic processes in the sense, not only we are not only going to monitor a particular area, but here we are going to monitor a wide range of area. Okay, so the focus of this 3D reconstruction is still on static object only. Although most sensors produce some 3D data, hardly any dynamic 3D reconstruction is presently being done. That has to be taken into consideration also. Okay, so the most dynamic software relies on geo visualization. I told you, right, what is geo visualization? Yes. So what is geo visualization? Geo visualization is a display of geographical information which is to be explored interactively in an effort of facilitating the process of hypothesis formation and knowledge. Okay. So this is about the monitoring the dynamic processes. Okay. So this is the data, so you have to know about the three-dimensional data collection and utilization process. As I said, it is a huge amount of data which we want to, if we want to go deep, means we can go, there are several amount of data available. So 3D feature data, surface data, so lots of data is available. But for your exam point of view, I think this would be more sufficient. Okay, so I will give you all the materials, even though it is not in your textbook. Don't worry, you could have it as an extra reference to gain knowledge also, not a problem. I just want to share one more thing, when to model a particular gist data in a three-dimensional process. Okay, so with that we will wind up today's class. So since that 3D feature, since the 3D GIS data can be more difficult to create and maintain than 2D data, modeling your data in 3 dimension should only be done when the extra effort will add values to your work. Okay, while some GIS feature such as aircraft location or underground wells, okay, naturally lend themselves to being modeled in 3D. Other data can be just as effective in 2D as in 3D itself. Okay, so for example, having a road network modeled in 3D might seem useful for investigating the gradients, but the additional effort to maintain that the third dimension, the z value, might outweigh the benefits. Okay, so what they're trying to say is, so some data are better in 2D rather than in 3D. So when they're trying to project in 3D, while they are struggling to put it in the third value, the z value, okay, the vertical line has an upper vertex and a lower vertex, each with the same two-dimensional coordinate only, but each is having some different z values. Okay, so that creates a problem for us. Okay, so these are the some important consideration when deciding to model your data in 3D. Okay, so what you can be doing is, this is a surface data. Yeah, this is when to model this data in 3D, right? So here are some points which some important consideration when deciding to model your data in 3D. Okay, so this data does not have to be modeled in 3D. It can be displayed inside a 3D view also. Okay, so height values from a surface can easily be added to 2D objects. So when you need them through the use of this geoprocessing tools, you could utilize it. Okay, so if the source of your z values is a surface, considered how often the that underlying surface changes or how it has been modified, or the more it changes, the less useful it will be to store the z value, because if it keeps on changing means then we have to constantly keep on updating the values, and then there will not be any use of the third dimension. So two dimension data is itself more sufficient for us. Okay, so if you decide to model some of your data in 3 dimension, means the most important decision will be the units of the z value. Okay, the units of the z value. So a solid understanding of what your z value represents will be very critical when you start editing that, maintaining them. Okay, so finally, this will, for example, if your data is in meter based, okay, uh, in an UTM zone, means then you should also model your z values as meters only. Okay, so if you can't give x and y axis in meters and keep your z values in centimeters, correct? So all the unit value has to be universal. Okay, so this will help you to interact with the data in an intuitive way, such as when you measure a 3D distance or move objects in an x, y and z axis. Okay, so I think that's it for this. Yes, so we have completed this process. Okay, so if you have any doubts, you can ask me, students. If you have any doubts, you can post your doubts in your chat box. Okay, so one last question for the students, I'll give you. A very simple question. I'll try to get another class in order to have a revision for you guys. Students, if you, those who want a problem, you can answer this question. So if you have any doubts, please post your doubts in the chat box, and we will wind up the class for today. So with this, we have completed the fourth unit. Your materials, videos and PPTs and presentations will be available in your college website by tonight. Don't worry. Thank you, students. Thank you for your participation. If you have any doubts, you can post your doubts in your comment section. If you got the answer for this question, you can also post it. Anjali has immediately posted. Very good, ma. Expecting some more answers. But Anjali, you can try again because 236 is a wrong answer. Even the staffs are feel free to answer this question. Not an issue. Satya 394. Very good pa. But sorry, 394 is also a wrong answer. Anybody else wants to answer? Okay, students. So yeah, I got another answer. Wow. Venkatesava Shankar, good. 694. 694. Sorry, it is also a wrong answer. Okay, students, let me break up the silence and you should read the question properly first. Yes, what is the question asked? They are not instructing you to crack the code. Vishnupriya, again 694. Sorry, ma. It is not the answer. Actually, you guys got diverted with the question because as previous question was to crack the code and you got the code, and this is not to crack the code. The question is actually, can you crack the code? That is the question. Okay. So this kind of logical questions can also be asked in your future interviews. So just for an experience, I asked this question. So the answer is actually yes or no. If you can crack the code, the answer is yes. If you can't crack the code, the answer is no. That's all. Very simple. So this is coming under topic called as thinking outside the box. Sorry to disappoint you guys, but this is also one lesson. So I hope you guys enjoyed it. So this question is for actually, can you crack the code? That is the question. So with this, we will wind up today's class. Thank you, students. Thank you for participating. And with much more interactive puzzles, we will meet in the next class. Okay, with the next unit. Okay. All the best, students. Prepare well. If there is another revision session available, we will definitely have a revision session. Don't worry. Okay. All the best, students. Thank you, students, and thank you, teachers.